Gretchen Johnson. I am the CEO of DaVinciSKY Group. We collectively, we own 3, I always call them kissing cousins, because we basically work in the energy engineering field, a lot with construction, inspections, maintenance, and building. So as we're taking a look at what we do, the 3 kissing cousins, OneSpan, FXD, and DaVinciSKY Engineering and Management. And those 3 groups make up our suite of products. So we get a lot of questions when it comes out to RFPs, because they are going to put you through the ringer. And if you are at a utility, most of the time I'm responding to you and telling you what I do for the environment. And then you send somebody out to make sure I'm doing it for the environment. And then they send somebody else to check out the person who is ensuring that I was doing it for the environment, right? So we usually have 3 to 4 people come and doing our little checks. But, you know, this is going to date me. Also, this will date me too. I always tell everybody I'm 55. I don't need a PowerPoint by now. But anyway, Jim said I had to have a PowerPoint, so I have a PowerPoint today. But, you know, when I first started off in the utility industry, we were very reactive. The pole literally had to be laying on the ground before we were going to send somebody to pick it back up. And we stayed in that era for such a long time. Then we decided, well, maybe we ought to be proactive, okay? Well, what are we going to do? How are we going to do that? Well, then we started with this thing now that we titled Data Asset Management. But back then it was just, this is a mess and we need to kind of get this straightened out so that everybody can see. So the director of transmission services can see, the director of distro can see, the engineering department can see, and let's create this visibility so that everybody can see. So we went down to data asset management, and at that time, helicopters had came onto the forefront. Now, guys, this is in the 90s, okay? So no drones, that was just on TV, the Jetsons, right? And that you watched it on Saturday mornings, and that was about all that you saw, right? So we were reactive. Then we got proactive. Then we thought, okay, now we can take it one step further and we're going to become predictive. Okay, so now what are we going to do for predictive? So we started talking about that. And we came through with helicopters and we realized, oh my goodness, these helicopters, they can set poles, they can set those great big lattice structures. We can bring them in 3s, you know, stacks of 3s. All we got to do is stack them up, design the stops and guides. We're going to torque those bad boys down. Then let's see if that helicopter can actually bring the conductor across. Can it do the static wire? So we slowly but surely started to revolutionize how we were using helicopters on the grid. And we realized that we could do it very efficiently. We realized that the OSHA incidents were a 1-to-1. I'm trying not to shake the stick, guys. They were 1-to-1. And so we began to kind of develop that industry. And as we developed that industry, we saw that we were basically building infrastructure at a rapid pace. We were building it very intelligently, we were efficient, but then came the environment, right? And we started looking at, that has a footprint, right? So then we had to start calculating our risk with the environment. And then we had to say, okay, we've got 120 mile, one of the very first power lines that I built, we had 120 miles to go, right? And we got shut down several times. You know, back then, we had to round up a couple of thousand snakes because we couldn't, you know, down south, we just whack them in 2 when we move on, you know. Well, we realized in Pennsylvania we couldn't do that, you know. So we had to we had to move to a different part of the line, and then we had to round them up. And this snake handler came in, and the state of Pennsylvania spent about $1.2 million in wrangling up snakes. We moved to the opposite end of the state until they came out of hibernation, and then they put them back in their original dens. They were marked. Everybody returned to their natural home site. And so you had projects that kind of went like that for, years and years and years. One time I was up in Maine, and I saw this lady out there with a bunch of college kids, and I said, "What are you doing?" And she says, "We're counting pellets." And I was like, "What kind of pellets? This is a job site. You're not cleared to be on this job site. You need to go get a hard hat, steel-toe shoes, and you need FR clothing, and, this is the rule." And she was like, "Well, no, there's actually," and I forget the species of little bunnies, but to my calculation, based on the poop pellets, she says there are probably 3,200 bunnies within a 2-mile radius. So, again, we got shut down, all right? So those are just some of the stories that, back in the 90s, early 2000s, that we were up against with the EPA and environmentalists. And, at first, I was kind of like, if you want power, get out of my way. I was one of those. I wore that hat. I certainly wore that hat because I did not want to be without power, and I didn't want you to be without power, and my job was to make sure that you had a power line, right? So, but then as things started coming and I began to start looking at the progression of how we were building power lines, what we were doing, I really started looking at the analytics of helicopters, the grid, and the regular process of getting power lines built, whether they be distro or whether they be your transmission lines. And even some substations, just depending on how remote they were. A lot of times we would do sling load, where we would bring in blocks, we would bring in concrete, we would bring in just a ton of other, necessities to build that remote substation that is up and over, maybe it was in between bodies of water and those kind of things. You've all been down to the Keys and you've seen those power lines that are, as they flank the sides of the one way in, one way out highways. So to work on those, it's almost impossible to have men, unless we're going to bring a barge out there, and then we're going to have our men climb up those, which is 1 hour and 30 minutes. Climb down is 1 hour and 30 minutes. So we've got 3 hours of climbing before we've done any work. So there's the human exhaustion level. Again, I think that we spoke to, where helicopters sometimes are needed, and that's a perfect example. Our company just did a lot of replacements on those tall structures, and there was no other way to get to them. So there are times when we do need helicopters, but there are times when drones are a better solution. And as drones have made their way in, I do believe the FAA kind of they're still holding back on us, I think. I think that I could get an amen from the front row that there's a lot that they could let go of to where we would be able to do a better job with work-safe procedures and things like that, so that the electrical utilities would be see that as more advantageous. Also, if we could get some funding just to do pilot projects, to take a look at some of those. And today, I'm just going to go through what I think are our 4 issues when looking at helicopters and when looking at drones. Because a lot of times we really need, when we're looking at a 3-mile build-out section versus a 121-mile build-out section, that's when we're going to see the differentiations. Because if we already know that we're going to mat for 1.5 miles and we're going to bring in probably, for 1.5 miles, we're probably going to do 7 trips of matting, or do we just take that helicopter, drop that man on that structure, and let him do what needs to be done? So there are times when helicopters can be even more efficient than the regular ground contractor. And 9 times out of 10, when I'm working in that arena, I'm working under a ground contractor that needs remote access for some reason. Okay, so now let's move to the drones. Okay, so you've kind of got a little bit about the helicopter, what the helicopters can and can't do, what the history is. So let's talk a little bit about the drones. Drones, they were very slow, very, very slow at piloting license. You know, they used to have one, I forget if it was called 610 or 609. We were one of the very first companies to actually go and get that licensure, and it was a bear. How many of you are here in Florida, from Florida? Okay, well, I'm gonna tell you, you have the hardest engineering test there is in the country. And I thought I was going to die. And I went to tech, you know, I mean, I really thought I'll just go down there, you know, take that test and come back. Oh, no. So it was quite the feat. And so, and especially the water portion, it was something else. So when we're taking a look, that is kind of the very first kind of red flag that went off for me, is that they are making this very difficult. What is it about the drones that are scaring and we're getting pushback from the FAA? What is it, right? So I think at first, nobody could just stand up and say, we really just don't know what to do with them, right? How to use them. Can we look at sectors where they are going to eventually expand? I think we were just talking about in the future, 2030, 40, 50. This is what I think is going to happen. I think we're going to have little bitty, let's go back to the Jetsons. We're going to have little bitty boxes out in certain substations. And those substations from point A to point B, they're going to release that drone. You're going to do it from an automated board, kind of like where your like storm centers look. It's going to have that kind of same look to it. And basically what's going to happen is they are going to open that box. That box is going to fly down through there, and then it's going to come back on autopilot. It's going to gather the data. It's going to be transmitting back to the SCADA. The SCADA is going to take that, intercept it into the system, and then it's going to be distributed to the transmission or distro director, whatever their setup is. That is what I see for in the future. But in the meantime, we've got some work to do on the drones with the FAA so we can rightfully step into what drones should be used for. So I think there's 4 things that are applicable to drones or helicopters. We've got safety, we've got data capture, because drones, we know drones can't set a tower. You know, right now we're kind of stuck with a helicopter. We know a drone can't go and do a 500 kV insulator change out. We know that that's not going to work for right now. So one of the best places for us to actually step off into the wild blue yonder is with inspections. And so that data capture and how we're capturing that, and then how we can feed that back to the utility, I think that that's a great starting point. And I'm going to be talking more about that on Thursday. And then, of course, production, and then cost. So let's kind of go through these 4 right quick. So safety. All right, so no matter the safety precautions that are in place, a helicopter's flight path includes many industrial safety concerns. No doubt about it, especially during comprehensive visual inspections that helicopters do. That helicopter is hovering in place. He might be hovering for HEC, human external cargo. You see the guys hanging from the ropes. That kind of application, that increases your safety. That is why we go through work-safe procedures. 9 times out of 10, that utility is asking for a work-safe procedure, where you are outlining and you are actually putting your work-safe procedures through a risk assessment. Very, very common. For drones, this does not exist yet. I think that does kind of, even though drones are better in heavier demographics, there is a level of security wrapped around the helicopters because they know that they'll clear out the public, whether it's a public park, whether it's over a school, whatever it is, they'll clear out the public. Whereas with drones, they don't clear it. right? So the human element up under drones still remains to be solved because no one is asking for work-safe procedures like we have to turn in for helicopters. So I think if the drone space could kind of get to where they're asking the same questions with the helicopters as they do with the helicopters, we're going to see that space get broader. When it comes to drones, these same industrial safety concerns are a non-factor. You know, most of the time we don't clear out the public to run a drone. However, where we do see some things, and y'all, I will never forget this. This was like 12 years ago. I had two little proteges up under me, and they were in their 20s, and they were such good little drone operators. And I bet you they had been playing like games. They had been gaming because they were so ambidextrous. And I thought, these kids are awesome. So I bought a couple of drones, and I took them out to the eastern seaboard. The first company that we bought was in Baltimore, Maryland. So I thought, this is perfect. We are going to go out there and we are going to run this drone. Then we're going to go up to Green Mountain Power, I'll never forget, and then we're going to do this demo. We are going to be on the map. I was so excited. We get out there. We didn't know that the mating season for the birds were going on, and sure enough, we put that drone up, and that drone came back, totally decrepit, $12,000 worth of damage. I laugh about it now, but I wasn't laughing then. I was crying. Literally sobbing, My demo was totally blown, But we never thought about that, right? We never thought about, what are the birds going to think? Where are the birds at? Where are they nesting? How do I identify that nest? What about the public below? Because after we were out near a boardwalk, so the drone starts spiraling and people are running. So here we had birds and people. We had totally missed the mark. So, and there's a lot of people that will say, oh, well, drones, they don't. Well, they have their own issues, and just like helicopters, waste fuel, when tail rotors go bad, how do we recycle that, and what are we doing, and what is even happening to where we can use recycled oil in a helicopter? I would just like to see that little bit, for us to be able to make some moves with that. But with the drones, we struggle with the batteries. We struggle with the battery pack, so there's safety concerns and, recycling issues, and each of them have their own. So that's kind of just a little splash in safety. Data capture. Okay, this is where we see the most. Both have mounted cameras. You can have a drone that has IR on it. The lenses are getting so much better. Carl Zeiss is now making a lens that's retrofitted. The IR capabilities, the LiDAR capabilities, all of those are, Mach speed right now. Wind turbulence is detrimental to each. With a helicopter, it's going to be at about 30 miles per hour. With a good pilot, with a very seasoned pilot, with a not good pilot or an unseasoned pilot, we're probably looking at about 23 to 22. He's going to want to land that ship. With a drone, we're looking at about 15 miles per hour. Okay, so wind either way is not, well, sometimes it can be your friend if it's going the way you want it to, but it's got to be, you've got to be headed in the right direction, north or south, east or west on that line. The helicopter used to struggle with imagery. Now the shutter speed has caught up. We have Trekka cameras out there with remote geodigital packages. Jeff Dockey, hopefully this is a check for you. Jeff Dockey, I love using his product. It's called Remote Geodigital. Basically, as it's going down the line, it's letting me know where those poles and those structures are located, and we can actually post pin drops, little thumbnails, to each one of that imagery, so that it's uploading as soon as you get back, you land back down. It just takes a lot of the back end work off. The QCC, you really aren't working as hard as you used to be able to see that. And also any land-based or ground-based inspections that you're doing, remote geodigital also works in tandem with that. And if you want any information about data, I'll be glad to have an offline. Well, I've tried it all, trust me. Helicopters can outpace drones. We're going to talk a little bit about this because sometimes it's not necessary for it to outpace, Storm, that's where we really need to see that outpacing. And then also we need to be airborne. And I know that Jim has got some questions for all of us, and I'll be talking a little bit about that with my experience on storm work. Neither is superior. Both of them have their place in the constructability of the power lines and the inspections. I like drones better in inspections, but like I said, we've got a lot of work to get these utilities to come over to our side. Production time constraints. Storm work is critical. Because we are still bound by ground, if we could eventually get to where we can release drones from the helicopters and release them to go back to a landing, I would like to envision that for our future so that the helicopter could go up over a 3-mile area. We could actually do drone to map with, that's a Esri product. I like using that in circumference with the remote geodigital along with our assets to where you could basically drop off drones within a segment. You would have them all on autopilot, and then from there, they would do the data capture, and then they would land at a specific place. That is kind of what I would like to eventually see with storm damage management. Budgets are huge. Budgets are the driving factor, right? And a lot of times when we go into the utilities and we're purporting that we can do drone work, they're like, yeah, but the helicopter's 2 miles away and we can get 20 miles done in, 2 hours with the helicopter, or we can do 20 miles for one day, because the sweet spot with the drone is 21 miles for the normal, and everybody has their definition of normal, for the normal drone capture for a utility. So again, the helicopter can outpace the drone, but I think one of the most viable arguments for that with a drone is that you can be actually looking at the data as it's being collected with the drone. So we would need to train some very intelligent linemen with our drones. And I saw you raise your eyebrow. You must expert utility guy. But one of my favorite places to use the drone is in QCC and Greenbelt. Doing a lot of the Greenbelt scans and doing the shape files and helping to use that on the forefront of a project. QCC, most of the time, we are required to give a 2 to 4 year warranty based on what we are doing for that utility. So the drone kind of says, oh, but there was a nut here when we left, and I see that you did maintenance, so that was your guy, not my guy, right? It kind of becomes a finger pointing. And then my other favorite place to actually use the drones is when we've just got one-offs, we've just got that wire that's flickering, train someone in that utility to basically be able to go up and look at that instead of dragging a helicopter out to do a 20-mile, a 2-mile look, You can easily get that quick look. And if the drone didn't pick up anything, I like for it to have IR on it because that will usually tell us a lot whether it's arcing or not. And usually you can tell by the wear and the tear on the component, and that will show us exactly what that looks like and where we think that that's stemming from. And then the cost, this all goes back to cost, drone versus helicopter, whether or not and how fast and efficient, a helicopter, an MD 500 usually should run you anywhere from $1,550 would be a great price. The average price is $1,650 to $1,700 per hour. That's all in. That's a helicopter, a pilot, and a mechanic. You always want a mechanic on site. Never do business with anybody that doesn't send you a mechanic with the helicopter. Otherwise, you're going to be paying because helicopters break. They do. They break. And you never know what might cause that. So always have a maintenance guy, and he can get you back up and running in, 30 minutes to a couple of hours, and that's very important. And then the other thing is the drone versus the helicopter is that we have to look at what's the sweet spot. It's really a mathematical, like I was saying, 21 miles a day is your sweet spot with the drone. And depending on how much that drone operator, for the capture and the drone operator together, that is what is going to help you make the most informed decision. How fast are you needing? What kind of line is it on? Is it a NERC line? Are you going to have to pay a fine if that line goes down? Those are the kind of questions that need to kind of help create what kind of machine you're going to use. I always say one is a flying tool. It's no different than a bucket truck. A helicopter is a flying bucket truck. Those are just tools to get what you need done, to get a clear perspective of what you need to be able to solve the problem. And that goes back to being predictive. Both of these are options to you, and both of them have their sweet spots. But we've got to be able to look, and we've also got to look back onto the rear of the project. If we bring in 7 truckloads of matting, should we not just use a helicopter to do the insulator change out? Or can I, on that inspection, can we go ahead and use the drone because we've got a day. We don't need to have this information in by the end of the day for that 500 kV line to go out. Let's use something that's more sustainable for our environment, such as a drone. So if anybody has any more questions, I'll be diving more into the drone inspections. We're going to talk a little bit more about the storm, but, and just the impacts and sustainability, reliability as we go into the storm discussion. And that is something that everybody needs to get involved with, because when it comes to storm and when we see those large storms, we are definitely missing the mark. And I'll be talking about that a little bit when Jim asks me his question. Thank you.